Hey everyone, today I want to show you a live demo of a project I've been working on called Pocket SSH. This is running on the ESP32S3 TDEC or TDEC Plus. The reason I like this device is because it has a physical keyboard, just like a BlackBerry. I know, it's old-fashioned. It's a completely portable terminal that lets me manage servers right from the palm of my hand. First, we need to get online. I've implemented a simple local command for this. I'm typing connect, followed by my SSID and password. You can see I'm typing a bit slowly here. Navigating this tiny keyboard takes some patience, especially with my thumbs, but the goal here isn't speed typing. It's about having utility in a compact form factor. Now for the real test. I'm not just connecting to a local Raspberry Pi, I'm going to SSH into a VM instance running on Google Cloud Platform. I'm using the standard SSH command syntax, the host IP, port 22, my username, and password. While I type this out, a quick note on how this works. The ESP32 is using libSSH2 to handle the protocol. It's actually performing a secure handshake and handling the encryption on this little chip. It's fascinating that we can do full SSH2 communication on a microcontroller this size. Watch the log, socket connected, handshake successful, authentication, and we are in. We have a live shared session with the Google Cloud server. Just to prove where we are, let's run neo fetch. There it is. We are running Ubuntu on E2 Medium instance on Google Cloud or controlled from this handheld ESP32 device. It works perfectly. I will get back to Google Cloud demo later. So that was the cloud, but realistically, I use this device most often right here in my home lab. I have several Raspberry Pi units running on my local network for various personal projects. Right now, I'm connecting to my Raspberry Pi 5. I'm doing a lot of testing with this board lately, so having a handheld terminal to check on it is super handy. Let me show you a practical use case. If I need to find a device's IP address quickly without going to my PC, I can just run ARP scan right from here. Since the TDEC screen is small, the output scrolls, but it's readable. I can easily see all the devices connected to my local network. It basically turns this TDEC into a portable network admin tool. Now for something a bit more experimental. I'm running the 1-bit LLM. This is the local large language model released by Microsoft. It's optimized enough to run directly on the Raspberry Pi. This setup is really significant for privacy since all information is stored and processed internally. A local LLM is absolutely essential for those who are concerned about their personal information being sent to the cloud. You own the data. I'm opening the interface now. Remember, the heavy lifting is being done by the Pi 5, but I'm controlling the prompt and reading the output entirely on the ESP32. Let's ask it a question, typing, and sending. For your information, you can easily select previously entered strings using the trackball. And there's the answer. It's generating text locally on the Pi and streaming it to my hand via SSH. It's pretty wild to see a private conversational AI running on local network being controlled by a pocket-sized microcontroller. For your information, swiping the screen to the left allows you to select and send certain keys. These are essential for terminal usage. For the next demo, I want to show you this setup. It's Raspberry Pi Zero connected to the ePaper display. Long-time viewers might recognize this one. I actually built it a while ago to display a live local map based on GPS data. If you missed that project and are interested in GPS tag, I put a link to that video up in the corner. After connecting via SSH, I'm using Python script to update the ePaper screen with the text I want. There's nothing particularly special about it, but I personally enjoy ePaper projects, so I prepared this demonstration. Finally, for the last demo, we are going back to Google Cloud. Here I have a camera module made by ArtCam. What's special about this is that it uses a massive 1-inch CMOS sensor. I'm actually planning to do a full review of this specific camera later, so keep an eye out for that. But today I want to show you how I control it. The key point here is networking. Even though this camera is physically right next to me, I have set it up to connect to my VM instance on Google Cloud. Now I'm using the TDEC to SSH into that same cloud instance. This means I can control this local camera from anywhere in the world, regardless of what network I'm on. The TDEC sends the command to the cloud, and the cloud commands the camera. Command sent, and it's starting and recording. I will quickly check the status to make sure it's running. It says it's currently recording. That's good. Let's send a command to stop the recording. Stopping recording. Recording stopped it successfully. I can check the local path of the saved file. All tests is done. Now let's check the local file to see if the recording was successful. And here's the result. The image quality from that 1-inch sensor is excellent. My garage is too dark right now, so there's some noise visible in the image, but I will definitely test this again during the daytime. But the main point is that I captured this entire clip using a remote command initiated from a microcontroller. So that's Pocket SSH. It's a fun build, but honestly, there are still a lot of features I need to add to make it a daily driver. But as a proof of concept for portable admin tool, it's incredible. This is all I have for today. Thank you for watching. I will see you in the next project.